All right, well, let's wrap it up by doing some long logarithms from previous exams. Just because they're old exams doesn't mean they're not useful. So Tara's aunt invests $2,000 for when she is born, and the interest rate is 3.5% per year. The rate does not change as long as it stays invested. The interest is added to the amount she's invested on her birthday. Okay, so there must be a reason why they're giving us that. The value of the investment after T years can be modeled by that equation. A equals 2000, 1.035 to the power of T, where A is the value of the investment. How long will it take before the value of the investment is 2,250? So in other words, we want to find when A equals 2250, and we want to solve it for T. Let's that one first off. So 2,250, taking it from this equation, is going to be equal to 2,000 times 1.035 to the power of T, and then solving for T. So let's do ourselves a favor and divide both sides by 2,000 before we start doing logs, and that's gonna, those zeros are gonna cancel. So that's gonna be 225 over 200, and I wonder if that's a nice, that's gonna be a nice number. 225 divided by 200, 1.125. Okay, 1.125. So let's look at what we've got. So 1.035t equals 1.125, and we want to get this t down here in front, so we're going to take the logs of both. So t times the log of 1.035 must be equal to the log. I mean, we've got to take the log of both sides. Should be a dot there. 1.125. So divide both sides through by that log of 1.35. So t must be equal to the log of 1.125 over the log of 1.035. So just as a side note, you cannot say that that's the log of 1.125 over 1.035. You could say that, but you would be wrong. You've got to do them both at the same time. So let's do it now. Let's clear that. So log of 0.125 is that. Divide that by the log of 1.035. Those brackets. 3.42 years. It's about what, 5 months? Would that be the correct answer? Well, no, it's not going to be the correct answer, because it tells us that the interest is added to the amount she has invested on her birthday. So it's going to be during the 4th year. So you can't withdraw the money after 3.42 years. You have got to wait for the next birthday for it to roll over. Okay. Tara reaches her 18th birthday. Calculate how much extra money would be worth if she leaves the money invested for another 3 years. So in other words, we want to find A of 21 minus A of 18, don't we? And in that case, we're just going to come along to our primary equation and work it out, the one that we've got up here. So that's going to be equal to 2000, 1.035 to the power of 21 minus 2000, 1.035 to the power of 18. You could play a bit of algebra games there, but no, let's just put those numbers in. So 2000, 1.035 to the power of 21 minus 2000, 1.035 to the power of 18, and we get $403.88. Don't forget the 88 cents. And that's that. 30 minutes after a patient is administered his first dose of medication, the amount of medication in his bloodstream reaches 224. The amount of medication in bloodstream decreases continuously by 20% each hour. Okay? The amount of medication M milligrams in the patient's bloodstream after it is administered can be modeled by the function M equals 224 times 0.8 to the power of t minus 0.5, where t is the time in hours since the drug was administered. Explain what the 0.8 bit means. Well, the 0.8 bit means it comes from here. So if we take off, so if we lose 20% each hour, it means that 80% is still left, which means that the dose after 1 hour is going to be equal to 80% the next hour. So 1 hour later, 80% of the last hour. That makes sense. You would reword that. Find the amount of medication administered initially. Well, I guess, so this is after, so it's 224 after the first 30 minutes. There we go, 30 minutes. So we would set t equal to 0 and solve. Okay, so the amount where time equals 0 is going to be 224 times 0.8 to the power of 0 minus 0.5. Okay. 224 0.8 to the power of 0.5 minus 0.5. 224 times 0.8 to the power of negative 0.5. 250.44. Which is 250 milligrams. Okay. Second dose of the medication can be administered sometime later, and again the amount of the medication in the patient's bloodstream for the second dose can be modeled by the same function as the first. Okay. The total amount of drug in the bloodstream must never exceed 300 milligrams. How long after administering the first dose can the second dose be administered? So you kind of think to yourself, if we add another 250 milligrams, we can't have more than 300. So we want to find out when does the amount in the bloodstream equal 50, don't we? Because if it's 50 or less, we're safe putting another 250 milligrams in. All right, so we want to set our m equal to 50 and solve this one for t. 224 times 0.8 t minus 0.5, and we want to solve for t. So again, let's make our life a bit easier. Divide both sides by 224, and I don't think that's going to be nice to us. So 50, they're going to be a nice 25 over 112. Not really, just keep it like that. So we want a bit of room. So 0.8 t minus 0.5 equals 50 over 224, and let's take the natural log. So t minus 0.5, natural log of 0.8 equals the natural log of this beastie here. And now we've got enough information to solve. So let's divide both sides by natural log of 0.8. And then add half to it. So t is going to be equal to this horrible thing here, all of this, plus 0.5. So natural log of 550 over, sorry, not 550, 50 over 224 over log of 0.8 plus 5. So let's take the log of the last answer. It's going to give us that. Divide that by the log of 0.8. Going to give us that. And then we're going to add 0.5 to that. 7.22 hours. Okay, I'm going to check that because that doesn't sound right. 7.22. So 224 times 0.8 t minus 0.5. I'm going to put t equals 7.22 in there. So 224 times 0.8, the power of 7. 2 minus 5, those brackets, 50. Okay, yep, that works. So 7.22 hours. So I guess just to be on the safe side, you'd say probably 7.5 hours. at least. All right, it's from 2010. Right, so the height of the antelope in meters can be modeled by the equation this, where t is the time in months, and t has to be strictly less than 36. Okay, so I guess the antelope's height will kind of like jump, and then after 36 months it'll kind of flatten off a bit, I bet. How long after its birth will the antelope reach a height of 1.2 meters? Give your answer to one decimal place. So in other words, we want to set height equal to 1.2 and then solve for t, don't we? Seems curiously easy. Have I missed something? No. Okay. 1.2 equals 0.0. Come on, rub out. 0, and it rubs out. 0.7 times 1.018 power t, and we want to solve for t. So let's divide both sides by 0.7. They're going to cancel. So 1.018 to the power of t equals 1.2 divided by 0.7. I don't know whether that's going to be a nice fraction. 0.2 divided by 0.7. Nope, it's not going to be a nice fraction. And then we're going to take the log of both sides. And then when we do that, the t comes out the front. Log 1.018. It doesn't matter what the base is, as long as it's the same base. And then t is going to be log of this thing here, 1.2 over 0.7 over log of 1.018. And we would grab our calculator and solve. So log 1.2 divided by 0.7 is that, and we're going to divide that by log of 1.018. 30.212 months. So during the 31st month. Seemed oddly easy. So t is less than 36, so our model holds. Okay, well, let's just move on. A chemical was used to treat the water in a swimming pool. The concentration at 8 AM is 200 milligrams per litre. The concentration of the chemical in the water reduces by 30% per hour. It is not safe to swim in the pool if the concentration is more than 25 milligrams per litre. Why would it be reduced? Okay. The concentration C milligrams of the chemical in the water after 8 AM is given by that. Do you really want to be swimming in something that's okay, but anyway, concentration is that. How many hours after 8 AM? So T is hours after 8 AM, so we've got the same unit. Will be safe to swim in the pool. All right. So in other words, all of this stuff was just a distraction. So we're going to set that equal to 25 and solve it. It seems, again, strangely easy. Okay. We're going to set that equal to 25. We're going to divide both sides by 200. They're going to cancel. So 0.7 to the power of t equals this. So it's going to be what, 1 over 8, isn't it? 25 divided by 200. Oh, it's late in the night. Yeah, 1 over 8, which is 0.125. Okay, so let's take the log of both sides. When we do that, the t comes out the front. And whatever we do to one side, we have to do the other side as well. So therefore t is going to be equal to log of 0.125 over the log of 0.7. Those are both going to be negative, but they're going to cancel. And don't, for goodness sake, again, don't think that that equals log of 0.125 over 0.7. You could say that, but you'd be wrong. Then we will grab our calculator. So log of 0.125 divided by log of 0.7 equals 5.83. 5.83 hours. So how many hours after 8 a.m. will it be safe to be in the pool? So that asks for the time. So 5.83. So time must be strictly greater than 5.83 hours. We're done. Hooray!